There's usually no one. There's usually no one on anyway.
Stand by. Oh, am I muted?
Nope.
No, you're not.
Unfortunately, you're not,
There's
Ron.
usually no one.
Thank you. But the
We're
word
rolling.
mute, we're rolling, and the word mute just came on my screen, just my part of it. Well, okay. Hello, everybody. Those of you who are laboring and the rest of us who are retired, welcome to the Labor Day version 2024 of the SBAU Astro Hour,
I like it.
Club's weekly cosmic vlog podcast out there into the eternity for the Santa Barbara Astronomical Unit from our hometown, our home man caves and offices. Some of the guys on the screen have observatories of their own. The Brain Trust, I'll introduce in a minute. This is Santa Barbara, California's longtime astrophysics club, and we meet on Zoom. We have for 3.5 years now. And you guys on YouTube watching this can throw questions at us or comments if you want. We kick it around, out of the world stuff every Monday morning. This is episode number 184 of the Astro Hour, September 2nd through the 8th. I'm your host, Ronnie Herron, and you can get the full story at sbau.org, www. This week, this 184th edition, we're going to talk about these cosmic topics. Fall is here. Fall is coming. Cassiopeia is in the northeast sky. We got a new moon tonight, allowing us to see zodiacal light. Pegasus is on display. There's even a new Andromegasus Big Dipper out there. My God. We're going to talk about Fomalhaut, a star, Saturn's moons. The inner planets are lined up on display. Mars is approaching an open star cluster, M35. Well, not literally, but visually anyway. The Apple Core Nebula, get this, converting magnitude to differences in brightness. To me, that's the same thing. I'm sorry, you're going to have your hands full, Mr. President.
It is. That's why it's easy to convert.
Well, okay, I read the notes. I've got it all written here. Let's meet the gang, and then we'll do the cartoons. Yeah, we're on target. Jerry Wilson, President, welcome back again.
Good morning.
Actually, you were on duty. You were on the screen even from, I guess, Southern Ireland or wherever you were over in the UK. And Pat Forgy and you guys are still dusting out everything. And welcome
Yeah,
back.
we got good connection in Cork.
Oh yeah, it's a dream vacation. Chuck McPartland, our outreach guy on the club, is on duty in front of the Ukrainian flag. He's married to another Pat, Pat McPartland, merchandise manager, as well as an incredible treasurer. Wonder what happened to our old treasurer. I miss his wide brim hat. We have on board Mr. Tim Crawford, whose real name is Tom, but
Howdy.
there's so many Toms in the club, he picked Tim. And he's a telescope expert as far as I'm concerned, and a questioner like me. He's married to Karen. Tom, who else do we have? Tom Whittemore, son of a gun.
Yeah.
He's married to Maureen, former instructor with his own lab out at Westmont College. And the man just weeps at night because he misses it so much. And he puts together a pretty damn good newsletter we get every month. Thank you very much. And this Friday night, we're going to be entertained and amazingly alerted about asteroids by our speaker at our first Friday meeting at Fleischman Auditorium. It'll be Dr. Maciero, Joe Maciero from Caltech, talking about hunting down bad asteroids. Mr. President, you send us these silly cartoons, and we'd like to start the show every week with our moments of levity and a thought provokers. Here's a thought provoker that I don't even remember seeing. Boeing Starliner astronauts stranded in space for 80 days will not return home until 2025. Well, I heard that news. What's new? Humanity has about 6 months to purchase 8 billion ape costumes for the ultimate prank.
Yeah.
Now, you didn't send that, or I didn't get it.
Yeah, I sent it, I thought.
I didn't get that one either.
Could be.
That's a good one. Those poor people don't seem to be any worse for wear. This one I can remember very well. Mysteries of Physics. Oh, no, that's the sharing the cat. Why is it a bad idea to major in physics? Well, 1/8 to the pi, about 45 degrees, is that the math is very hard. The other 7/8, the other 320 degrees, you'll never enjoy action movies again, as you'll always notice the wrong physics. I call it the Neil deGrasse Tyson effect. Absolutely right. Meeting is being recorded. Now, this one needs some explanation. What the heck's going on? Why not? What is going on?
This is from the movie about Bilbo, and he is supposed to be returning the ring to Frodo, but he decides to keep it. But someone has photoshopped in an old type of plug, and it looks like the British type of plug. And it's out of date. No one uses that anymore. But he says, why shouldn't I keep it? So he doesn't want to throw it out. I have a box full of old plugs that I keep just in case.
So this is a scene from the movie, but they photoshopped out the ring and put in an old power cord charger.
Yeah.
Why shouldn't I keep it? Okay, I know who that actor is. This is interesting and also worrying. We've only started using robots ourselves. Down in the ocean, scientists have found 30 potential new species at the bottom of the sea using AI and robots taking over the sea. My God.
Pretty advanced things there.
Can be worrying. You're right. It's a thought provoker. Here is, are these the Pac-Men begging for the aliens
Oh,
to
yeah. I remember this.
Yeah, take us, welcome. Then they're all getting beamed up. Yes,
Why do I
chosen?
why am I picturing an old version of the Twilight Zone where "To Serve Man" was the
that was the
book.
similar.
It turns out they were going to cook us. Good luck.
Except this one has different plans. That's just the Roomba automatically cleaning the earth.
Oh, that's what the V's mean. It's cleaning people.
Yeah, that's the motor on the Roomba.
Got it. Okay.
When our cat is fascinated by the Roomba.
You got one, huh?
Yeah, we got 2 Roombas and 1 cat.
Will they ride on it? Because I've seen videos.
They're almost. They don't
Almost
really
ready to
ride.
ride on
One
this.
just follows it around, sniffing it perpetually.
I know, but for most pets, that's an animal. That's a threat.
Yeah.
And you had 2, but 1 disappeared.
Yeah.
Yeah. Right.
Great moments in science. I can't see this one.
I was worried about this. I enhanced it quite a bit, but then it faded out again.
Can
It
you
shows
dim it?
great moments in science. It shows Newton with a apple bouncing off his head.
Right,
Shows Pasteur with a carton of milk bouncing off his head.
right.
It shows Curie with a radioactive material, something bouncing off her head.
Yeah.
And then it shows Schrodinger with a clawing cat on his head.
The one that's missing is Einstein, but you can't see him because he was swallowed up immediately by a black hole.
Black hole, yeah.
Yeah. More mysteries of physics. You guys will relate to this. How come this is not smaller? They've just shaved all that fur off the cat, and it makes a bigger pile than the cat, and yet the cat hasn't shrunk any at all. That's good. Which cartoon is this? Mysteries of, okay. All right, I've added one to this one. You know, STEM becomes STEAM. In this case, I'm STEM. I'm in STEM. Shenanigans, tomfoolery, escapades, and mischief. STEAM adds art with an A, and I add the A as astrology.
That's right. No, he didn't say that, folks. He slipped. It was an error.
I know, but we got to remember art. And okay, here's the one we talked about before going on the air. You got to figure out what you're reading at the bottom. King George is IV. It's
his IV, and there's his IV right there.
That's it.
That's what I couldn't figure that one out.
It took me a long time to look at too. I couldn't figure it, but I got it.
I don't know where you get these things, but that's a good one. What's that fast food that has a king?
Burger King.
Burger King. That's the reason it's king. All right, got it. Well, you want to start off by converting magnitude to brightness and tell us what's the difference, or you got your own agenda in mind? The night sky, Mr. President.
Follow the MC.
Okay. It's good stuff. Here's the formula to use. Triangle M.
According to Astronomy magazine, and I didn't know this, the magnitude system is defined so that 5 magnitudes is exactly equal to a brightness change of 100 to 1.
That's right.
So 1 magnitude is a brightness difference of the 5th root of 100.
Right.
Which you can get out your calculator and figure out, and it comes out to 2.512. So, and this is the formula. that they gave for that. So one magnitude in brightness is equal to 2.5 times. Now I've got me. Byron's got me doing this too. Magnitude difference. No, brightness difference is 2.5 times the magnitude difference.
Mhm.
So two stars that are one magnitude apart are 2.5 times brighter or less bright than the other.
Huh.
Does our sun have a magnitude rating?
Yes,
How many minus?
I think it's in the minus 27 area.
26.
Minus 26.
26, okay.
26.
And then a full moon is a minus as well, obviously.
Minus 13.
Yeah.
Are any stars in the minus?
Sure.
Sirius.
Yeah.
How about Venus, the planet?
Minus
Yeah.
4.
That's frequently, I think, -4 right now.
It's
Mhm.
minus 3.9 right now, but yeah, it can go -4.
Yeah.
Mhm.
And the thing is, it's brightest when it's the thinnest crescent.
Mhm.
Really?
'Cause it's a lot closer to us.
And in a dark
Okay.
sky, it will cast shadows.
Yeah.
Well, we'll cover that in a minute here with the parade of planets, the inner
There
planets.
was when I was first starting out in the 60s and reading all these introductory things to astronomy, someone pointed out that on a clear, dark night, and I've never been apparently in that situation, you can actually cast a shadow from the light of the Milky Way.
Yes.
No
Yeah.
kidding.
So several nights up in Lassen at the devastated area, you could see the glow of the Milky Way in the summertime when Milky Way is right over your head on the asphalt, right
Okay.
on it. Yeah,
That counts.
yeah.
Well, are you saying that big, large angled light from the Milky Way has what's the word I'm looking for? Has a magnitude
Yeah.
It
Oh, yeah.
does.
Mm-hmm.
for the whole thing?
You'll find also in descriptions of what we call faint fuzzies, they'll give you magnitudes. For example, Messier objects in galaxies are frequently around magnitude 8.
Mm-hmm.
So it doesn't mean that it's like a star of magnitude 8
Right.
because the light of the nebula is spread over a big area. So it looks much fainter.
Yeah. That's integrated magnitude instead of
That's
just
right.
straight magnitude.
But there are individual stars in that Milky Way. Obviously, the Milky Way is made up of stars.
Yeah.
How in the
Yeah. Unresolved.
Oh, okay.
And there are beetles, I think it's dung beetles actually, that use the
Yeah.
Milky Way to
That's
navigate.
right. Yeah.
Really?
Yeah.
Yes. Yeah. Yeah. So actually navigate by the Milky Way.
Huh.
Yeah.
Interesting. I think I grew up around dung beetles. They're little black bugs that roll round,
Yeah.
you know what?
Mhm.
don't they?
Yeah. They roll the dung.
Roll the dung.
Yeah.
What does the triangle in AM mean?
Oh,
Delta.
this is the Greek letter delta,
Change.
which means a change in magnitude.
Right.
Oh,
So they're talking about a brightness difference. So it has to be related to a magnitude difference. So this is the magnitude difference. So if you were looking at, say, Vega, what is Vega's 1
Or 0.
or 0?
About 0, I think.
Yeah, so you'd have to compare it to something else and take the magnitude difference and then see that that is multiplied by 2.5 to get the brightness difference.
so are you saying that we have two scales? One is magnitude, and there's another that I don't even know about that gives totally different numbers?
Yes.
I've
Well,
never,
what's most used is the magnitude scale.
Right.
I've never seen the other one. I don't know what
Well, that's
It's done
brightness.
yeah, go ahead.
Perceived brightness.
Yeah.
would it have that little triangle, that delta M next to it?
No, that's only if you're subtracting 2 to get a difference.
Yeah, that's the
Oh.
difference between two of them.
Yeah.
So
Ron,
a lot of astronomy
Yeah.
that we practice, astronomy evolved from, what is
Ancient Greek, in this
yeah,
case.
ancient Greek and Arab things where everything was visual. And
Right.
so it's based on measures of the eye and stuff. Now we do it by instrument. And so we have photometric brightness, which we can measure. But magnitude was a measurement of what the eye saw.
Yeah.
And we
So
have a
Ron,
lot of that with even when telescopes started getting big, like the 36-inch refractor on Lick Observatory. The resolution of those telescopes was figured out based on formulas that were for the eye. And you can actually resolve things well beyond the classical resolution limit by using instruments and algorithms to reduce the data. There's more data in the there's more data in the image than the human eye can really easily extract. The classical limit of resolution is if you imagine two stars close by, that they both produce a diffraction disk. And the first maximum, or the first minimum, the first dark ring of one star pattern exactly overlays the brightest central or airy disk of the other one. That was the theoretical limit of resolution optically. And telescopes were rated in their resolution.
But don't we have a number of variables out there that would go up and down?
Yeah.
Yeah, that too, in brightness.
Okay, so they don't get a complete, solid, never-ending magnitude. It's just depending on when you see it.
And no star really does. All stars evolve and go through brightness changes.
Yeah,
Is that right? And so they just
really slowly.
But that's over millions of years. Yeah.
Yeah.
Well, is there a central booking house that covers all this and has monitors it all and keeps keeps this up on tab?
There are actually different magnitude measurements based on what color filter or what kind of filter you use to measure it, because you're looking at different things, different wavelengths.
Yeah, the American Association of Variable Star Observers tracks all these things. And as Chuck points out, for instrumentation and photometry, they have different symbols, V for visual, and then different filters that they look at it, because the stars have different brightness distributions spectrally.
Well, back in my early life, the word magnitude didn't mean brightness. You look it up, I think it has a different definition, doesn't it? It doesn't mean bright.
Colloquially, it means, just some magnitude, some scale.
Size, really, or quantity.
Right.
And this all goes back to Hipparchus, I think it was, who was building a star catalog. And he says, these bright stars are stars of the first magnitude.
Right.
And then these dimmer stars are of the second magnitude. And that's why it goes opposite to what you expect, because it's like a rating. These are the number 1 stars, and then the number 2 stars, and then the number 3 stars. And so that's why the magnitude scale goes opposite of what you might expect, where, a smaller number is a brighter object.
So it was the Greeks that started cataloging and categorizing, not the Arabs.
Oh, the Greeks probably did it before the Arabs, but a lot of it goes back to Sumeria, and that would be sort of Arabic.
2.512. Where did they come up with that number?
Okay, that's because he said first magnitude, second magnitude, third magnitude, and he listed the stars. And when they actually got photometry and they could do a measure of the brightness and get a number, they found that it was about this 2.512, because your eye has a logarithmic response.
Okay, got it.
And Ron, it's basically if two stars have a difference in magnitude, okay, of 5, then in brightness they differ by 100 times. So it turns out those two numbers are related by the 5th root of 100. So if you take your calculator, you take 100 to the 1/5 power, you will find it's a repeating decimal.
Oh, to the 1/5 power. 1/5 power.
1/5 power.
Okay.
It's logarithmic scale.
Yeah.
Like Chuck just said.
It's the 5th root.
Yeah.
Exactly. Yeah. And it was, Hipparchus who started the magnitude thing, like Chuck said. And then in the 1800s, they wanted to have a much more precise way of establishing magnitude against brightness. And so they came up with this difference of 5, okay, and magnitude is a brightness enhancement, if you like, of 100. Okay, it's logarithmic. It's not linear.
But now the planets are up there too, and they're usually brighter, are they not? Especially the inner ones?
Yeah.
Yeah. Saturn last night at about 8:30 looked like, a glowing yellow ball with my eyes. I didn't bring my binoculars out, but it was probably in the neighborhood of, 1 to 2, maybe second magnitude. I'm just guessing.
Second magnitude's Polaris, so maybe -2, you mean?
Yeah.
Oh, mine's too. Yeah, it was pretty bright. And when I first saw it, I was thinking, geez, there's no star out there. This is just below Pisces, you know. It must be Saturn. Yeah, and it was. It was.
Well, we're going to talk about Saturn approaching one of the star clusters,
No,
Yeah,
that's
we'll get to that.
or is that Mars? I'm sorry.
No,
Yeah.
no, Mars has been wandering by like the Beehive, stuff like that recently.
Got it. Okay, now we know how to convert magnitude difference to brightness.
Mhm.
Who would have thought? I love it.
Use it all the time.
I love that concave horizon we always see with this night sky.
That's the effect of the wide field of view that I picked here.
Yeah.
Well,
If I moved the planetarium software up so the horizon is right here, it would be flat.
would we
Yeah,
see
As we're
less?
looking up, it's concave.
Okay, this is like fisheye almost.
Yeah, it's actually the way your eye sees things, but your
Oh.
brain corrects for the curve.
Gotcha.
By the
Fantastic.
way, 104 is up there to the left of Capricorn, right?
M104.
Yeah.
104 is no, that's Sombrero, Tim.
Yeah. Isn't that up to the left of Denham Algidi?
No, it's
Oh,
off
no.
of
Oh,
Corvus
okay.
the Crow. It's between Corvus and Virgo.
Oh, that's right. Okay.
Right.
There's something in here that I used to look at near yeah.
M2 is a nice globular. M30.
Mm-hmm.
And, oh, yeah. Well, now that we're zoomed in, you got all these globulars: 75, 72, 73.
Yeah.
There's Pluto. Can
So
you guys see Pluto in your scopes?
I have, well, not in my telescope. I've seen it at 61 inch.
You can, I mean, you can see it, but the thing is knowing which thing
Yeah.
is
Yeah, which
Pluto.
is it.
It just looks like a star.
You will need a bigger amateur scope, 10 or 12 inches or something.
Yeah.
Well, can you also see that other dwarf planet that's out there in the Kuiper Belt?
Eurus?
No,
I don't know.
not without a big scope.
You could with a camera.
Yeah, time exposure.
So Ron, just a comment here. So Jerry's called up about midnight tonight, and you can see Fomalhaut over the southeast. So for those of you who are up at 5 a.m, like me, and you have a good horizon, you can see Canopus just coming up, and then if you look to the northeast, you can see Regulus. It's kind of an interesting. So when you see Canopus, you know that Regulus is now up. So the front end of the lion, kind of neat.
I don't see Canopus here.
Well, you're at
Oh,
the wrong
no,
time.
this is at midnight. So Jerry, you'll see Canopus if you got a good horizon around 5 a.m, just roughly.
Oh, okay. So this horizon is meant to represent our south, which is the ocean.
Mm-hmm.
You have a very good chance of seeing Fomolo. And on the talking points, I called it the Fomolo hour because I used to listen to this radio show that was like 5 minutes long that was broadcast from McDonald Observatory back in the 70s and 80s. And they called it the Fomolo hour. And for some reason, when I tune in, I keep getting that one. So
And Pomelo is part of Pisces Austrinius.
Austrinius.
Yeah, the southern fish.
That's an asterism.
It's a
That's
constellation.
Constellation, the border constellation is here. The stick figure asterism is here. I think this is a fairly poor asterism. I didn't like the asterisms that this planetarium shows.
It's a large fish, and Fomolo is his mouth.
Mm-hmm.
And then Aquarius up there, I don't know why they drew him this way, but yeah, he's usually shown as pouring water down into the mouth of the fish.
Right.
Yeah.
Right.
Stick figures in the sky.
Yeah.
Interesting.
Hey, Chuck, would you like the Jeopardy question today in the New York Times? It's kind of fun. It's right in your wheelhouse.
Okay.
Want it? You are a very smart person, okay? If you know the constellation of Table Mountain.
Mensa.
Good job. You nailed it.
Good grief.
Mensa. Yeah, Mensa.
Yeah, which we can't see, Ron. Mensa is like almost on the southern pole in the sky. It's way down there.
Anyway,
I thought-
Fomolo was a bright star in the south. You get a small part of the year where you can see it. rise here. This is midnight tomorrow night, but it's going to look the same tonight at midnight.
Very
And
lonely, Jerry. Very lonely
What?
sky there.
Yeah, it's often called the lonely one because it's the only first magnitude star in that part of the sky.
Yeah.
And it has a disk around it of debris and potentially exoplanets,
Mm-hmm.
25 light years away.
Not that far.
Yeah.
And we get a new moon, what, during the 6 o'clock hour?
Yeah.
Yeah. I saw it 2 mornings ago and it was pretty slim.
Whoa.
So,
Now this is 11 o'clock at night,
okay.
tomorrow night, and it's emphasizing the great square of Pegasus
Mhm.
right there. And it is an easy constellation to find, and it signals really the fall when you see this in the evening like that. We'll see it better in the winter if the skies are clear.
Somehow that represents a flying horse.
Mhm.
Oh,
Upside down.
Oh,
Yeah,
it's
he's upside down. You
Oh,
see Enif up there is his nose
Yeah. Enif.
up to the right. That's the nose. And then there's his head there and his neck. And then the square is like his forebody. And then sticking up are some hooves, some legs and hooves. But he ends at the waistline. He's only half a horse. So when he was put up into the sky, his rear half cracked off and fell back to earth and brought forth politicians.
Now, if you look real close, one of the great square things, Alpheratz, is actually over the border in Andromeda,
Mhm.
but we still call that one of the great square stars.
Mhm.
Alpheratz. Sounds Arabic.
Yes.
Now, if you go through the diagonally across the great square, you go down here and you end up in the region of Merak, which is halfway between M31 and M33.
Mhm.
On a dark night, both of these, or each of these, is visible to the naked eye.
Mhm.
And Andromeda is a constellation.
Yeah.
It is a constellation. It's this one here. I
But
think
what-
it's some chick chained to a rock or something, or sitting
Yeah.
on the queen chair.
It's the daughter, the princess of Ethiopia, the daughter of Cassiopeia and
Right.
Cepheus, chained to a rock at the edge of the ocean.
Right.
What is the galaxy itself represent in that?
Right here.
I know, but is it part of her? Is it her
It's
navel?
within
or-
that constellation's boundaries.
Yeah,
Oh.
they did not incorporate that in the stick figure
Oh, they
asterisk.
didn't. Okay. That's why I'm on board, gentlemen, to ask these stupid questions the laymen want to know.
Inquiring minds want to know.
Oh, yeah, especially mine.
So here we are clearing the eastern horizon. Let's see, Perseus is over here. We'll see more of this later. This is Cassiopeia.
And that means double cluster.
Yeah,
Mhm.
we'll see that a little bit too. And what else? Oh, yes, Saturn is down here,
Mhm.
Neptune. And we'll see Saturn coming up in a little bit too.
I could see it at 8:30 last night, Jerry.
Okay, yeah,
Yeah.
it's near opposition, so you should be able to see it all night,
Mhm.
provided there's no marine layer.
Wow, see all the way to Neptune.
Now, here's the planets near the sun. They're not all in the morning sky, but part of them, some of them are.
Mhm.
Our inner neighbors.
You what?
Our inner neighbors.
Well,
Mhm.
no, Venus is in the evening sky.
Yeah.
Right.
This, yeah, it means like apparently near the sun.
Yeah.
So, and here we have Mercury. This is at 6 a.m. I don't think it's quite this dark at 6 a.m.
No.
But still, Mercury's bright enough that you can see it. Mercury is on the other side of the sun. It's fully illuminated. And right above it is Cancer and the Beehive cluster right at the center of Cancer.
Which one of the planets, Mr. President, did you say in your notes was in opposition?
Saturn.
Oh,
Saturday.
okay.
Yeah. This Saturday, technically.
We've all, okay, we left her behind. Now inside. Wow.
And for the evening stars, at 6 in the eve. Oh, this is 6 a.m. This is the
Yeah.
morning.
Yeah. So
So
that's gonna be
we have-
Jupiter and Mars. Yeah.
Yeah,
There you go.
Jupiter and Mars, they're coming close together.
And
Oh,
this is like midnight one-ish. This is
Yeah.
that they're rising,
Mhm.
but by 6 they're high.
Yeah,
So we'll see Jupiter probably next month in the
Yeah.
east.
Yeah.
in the
Okay.
evening.
All right.
So this is M35, a very nice open cluster down here. I learned a new name for a star down here, Propus.
Yeah, it means ankle.
Yeah. So, yeah, my Propus hurts. Anyway, this is Mars. Mars is going to get quite close to this,
Mhm.
35. And M1 is here about halfway between Jupiter and Mars.
Mhm.
This is the great planetary nebula that's
No,
technically
no.
not a
Supernova
planetary
remnant.
nebula.
That's supernova.
I just did that to rattle Chuck's chain.
Crab. It's the crab.
Yeah, it's a Crab Nebula.
It's the only supernova remnant in the Messier catalog.
Yeah.
Yeah,
And it's apparently the first one he named, right?
Yeah.
the first one he listed. It's not clear to me what order he put them together in and whether he saw them all or not. I just heard about them.
And Lord Ross is the one that kind of coined the name for the crab nebula,
Yeah, his drawings kind of look like a horseshoe crab.
or even a lobster. It was weird.
Yeah,
There's
So-
Aldebaran.
but M1 is the one that you can actually make and have people have made a movie of it because it is expanding rapidly from the supernova explosion. What was it, 1056 or something?
And 54, July 4th.
10, okay. And so that's not that long ago, 1,000 years. And so it's visibly moving. And if you take pictures of it, which people have from the 1800s to now, you can find these pictures and overlay them. And you can see the motion of some stars, but you can see the structure of M1 expanding.
Banding.
Yeah,
Well, it's a blast wave.
yeah, it's a blast wave.
So in other words, you could track a line where it's gone across the sky.
No, not where
Oh.
it's moving around the sky, but where it's looking at where it's getting bigger.
Oh, it's also the name of a military weapon.
Yeah.
That's
What-
an M1A1.
Is that what it is? Okay.
M1A2 for the current model,
Oh, yeah, okay. Got to keep up on my tanks.
if you're talking tanks, but M1
Yeah.
is the World War II semi-automatic rifle
Right.
Wow.
or carbine. That's confusing.
Well, you're up in my sign, Taurus.
So let's,
No bull, huh?
yeah,
Well,
Yeah.
let us guess in this show, yeah.
so the beehive cluster
Mhm.
is.
You've lost Cancer. You got to go
Yeah,
down.
it's down below. You got to push your
Oh,
screen up.
yeah, okay, that's why I don't see it. But we're getting up on this one, we have
The Pleiades.
Pleiades up here.
Mhm.
And the software has added all the names of the
Stars.
9
Stars in the little
major
different.
stars in it. It's a cluster that actually has a lot of stars in it.
Mhm.
But to the naked eye, if you have good eyes, which I used to, it looks like a little teeny little dipper
Mhm.
in shape.
If you point your telescope at it, do you see most of the stars or can you go individually?
Depends on the field of view of your telescope.
Right.
It's
Most
a wonderful
telescopes-
binocular object. It's a beautiful binocular.
Most telescopes we have will not show the whole cluster at once.
Really? But when you look at a cluster, what are you seeing? Just a fuzz ball or a bunch of
No, you
individual?
see the individual stars. This is a
Oh.
very close cluster. And it has a lot of different occupants from very bright stars to very faint. Of course, you see the brightest stars depending on what kind of scope you're looking through. But going real faint, there's a lot of stuff. And there's even a nebulosity in front of the nebula or the star
Right.
cluster that the star cluster is passing through. It's not part of the cluster,
Right.
but the stars illuminate the
Mhm.
gas cloud it's passing behind.
It's dust particles and they scatter the blue light, so it's a bluish
Yeah.
nebulosity.
Yeah.
But science doesn't know whether all those stars in the clusters are orbiting a black hole.
No, this is an open cluster. The only candidates for that are really tight old globular clusters.
Or they might have black holes, because there are black holes, roving around the galaxy beyond the, supermassive in the middle. Old sag.
Apparently there are, yes. As I recall from another talk, there's about 37 known and identified black holes that are loose running through the galaxy.
And they're probably all over this picture, but we just can't see them. They're in the black.
Yeah, I
Amazing.
don't know if they probably are closer to the plane of the galaxy. So if you got the Milky Way in it, which we do here, they're probably along that
Oh, gotcha.
in that region.
Because that's where you get very massive stars that live fast and die young and leave black holes.
Mhm.
Wow. And then there are rogue planets that are roving around, I hear. You'll
Yeah.
never see them.
Unless you
Somehow
have a
they see them
telescope.
because they've identified them and tracked them.
God, I wonder if there's life on a rogue planet that doesn't have a sun. I don't think they could live, could they?
Not
Could be
unless
if-
they've got a space heater.
Yeah, or geothermal,
Yeah, that's
activity.
right. Yeah.
Okay, interesting. It's another subject, another time, gentlemen. Fascinating. Just love it.
Okay, so here is tomorrow morning at 7. No, this is the evening, 7:30
evening.
p.m. It's not going to be this dark at 7:30. Here's the glow from the sun that has just set, with part of the Leo sticking out here, with the Leo triplet here just about to set. The moon is just 1 day past new, so it's a very thin crescent. But this is part of the planets around the sun.
Yeah,
And
and
this is,
Tim, there's your 104
yeah.
right on the horizon there. There's your 104, the sombrero. You were asking about that.
Down and
Yeah.
left.
Oh,
from
there it
Venus.
is. Okay, yeah.
The sombrero
Yeah.
galaxy.
Sombrero Galaxy.
Yeah.
Big
Really
galaxy
pretty.
looks like a Mexican hat.
Now I did see Venus last night at about this time.
Me too.
Super bright.
Yep. And
So
right
this-
now the ecliptic is very
Shallow.
The inclination is very shallow. So Venus, although it's pretty easy to get, okay, it's pretty close to the horizon too.
Now this is 7:30.
PM.
This is 7:30 p.m.
Okay,
According
You're
to the
talking about
planetary
sundown.
software.
Yeah,
Yeah.
right around sundown, Tim.
okay.
See, here's the glow of the sun setting.
Mhm,
The sky is over dark for that time, actually.
mhm, mhm,
But Arcturus starts to show a little after that.
mhm, mhm.
And did I miss the names of all those clustered yellow numbers in the center? What?
That's the
Yeah.
Virgo cluster.
That's
Yeah.
Virgo.
Okay.
This is a part of the sky that we're looking out almost at the north pole of the galaxy,
Mhm.
we're looking up from the disk of the galaxy, and we're looking at another galaxy cluster out there in space. And this is overhead in about midnight or the evenings in the spring,
Mhm.
March and April.
Well, all those numbers are in a star cluster? Is that what you're saying?
They're
Those
in
are
a galaxy cluster.
They're galaxies.
Oh, galaxies. Oh, I'm sorry.
Yeah.
So anything yellow is a galaxy on this.
No, it's a Messier object.
Yeah.
It's just Messier.
Oh, Messier.
Most of them are galaxies here.
Mhm. But
Even up
like
here.
M3, Ron, M3 up there.
Yeah.
Yeah, that's a globular. It's a beautiful globular. It's a Tim Crawford favorite.
Oh yeah. But just over a third between Arcturus and Corcaroli.
That's right. Mhm.
And my understanding is old man Messier thought he was looking at comets.
He's looking for him.
Yeah.
And he found some.
Mhm.
So he concluded that all these things we now know as galaxies and star clusters are comets, or not comets.
Not
He thought-
comets. Yeah.
Right.
And here's my two favorite stars.
Yeah. Yep.
Well, pronounce them. Can't read them.
Zubin el-Shamali and
Oh.
Zubin el-Ganubi.
That's my law firm.
So, Sean,
That's the northern
No,
and southern
that's-
claws of the scorpion.
yeah.
Gotcha.
The law firm is Dewey, Cheatham and Howe.
Right.
That's from the Three Stooges.
You're right.
So one time we used to, when I was a kid, we'd go to the Griffith Observatory because they had a new show every month.
Mhm.
And we didn't catch all of them, but we'd catch a lot. And the announcer, the narrator, was talking about it, and he said he'd received a phone call from someone in Hollywood that they wanted to name their new children, who were twin girls. They wanted to have a very stellar name for the girls. Could he suggest something? And so he suggested Zubin El Ghanoubi and Zubin El Shamali. I showed them backwards there, but I think she was fairly disappointed in the names.
Sean showed me those up at Refugio the last time. He says, "You know what these are?" And I said, "Is this one Al Janubi?" And he goes, "That's right." You know, and then he named them, and I was going, "Holy man, I missed half the name."
Yeah. Zubin's a claw, Tim. Means a claw in Arabic.
Zubin is the claw. Okay, it's northern and southern.
Northern
claw,
and southern claw, right?
Yeah, it's amazing. Yeah, I was very interested in that. The names are cool.
And they're part of Libra there in the zodiac, and zodiac means band of the animals, because all the constellations in the zodiac were animals or people until the Romans stuck in Libra because they saw Virgo as Astrea, the goddess of justice. And so these two stars used to belong to the Scorpion. They were the claws of the Scorpion until the Romans meddled with things.
Ah. Well, are they German names or Arabic?
No, they're
Arabic.
Arabic. See, a little Arabic goes a long way when you're looking at the stars in the night sky.
Wow. And they're right in Libra.
I like the explanation we came up with for the Arabic math system, algebra, which means the sought after.
I finally got the difference between logarithm and algorithm apart.
Well, now you've got log base 10 and you've got log Napierian logs.
Oh,
so you won't get into
that. So there's two girls you're saying out there named Zubin Ishmael and
no, I think that was what he recommended probably.
Oh, they didn't do it.
I don't think he would. I haven't heard about any people in Hollywood named that.
Well,
Chuck had another name that we did at a star party once. It was really interesting. I wish I could remember it just to give him the hint, because it was pretty good. It's really
my favorite names for these things in Hollywood was Moon Unit and Dweezil.
Yeah.
These were Frank Zappa's two kids.
Yeah.
And they didn't change their names. They kept those names through their adult life.
Did they really?
Yeah.
God.
Tim, were you thinking of Sidus Ludovicianum?
Yes.
Okay. Yeah.
That's a really neat story. It's maybe for another time.
Yeah. Different part of the sky.
Yeah.
Okay, here we are transported to Cerro something or other in Chile.
Zodiacal light.
Yeah.
Don't expect it this bright around here.
Cerro Paranal, Chile. Yeah. This is almost overwhelming. But this is sunlight scattering off a disk of dust and debris in our solar system from passing comets. So there's a hell of a meteor storm waiting out there.
Well, concentrated parts are what's called radiance of meteors showers, right?
Well, that's just the center of where they seem to appear from.
Yeah.
So like I said, concentrated areas. Yeah.
Apparently concentrated areas, not necessarily a concentration. It's how we run into it. Think of meteors as you're in a car during a rainstorm and the rain hits the windshield, but you're not seeing anything from the back. No rain hits the back window while you're moving.
Well, something occurred to me that I thought I'd ask you, gentlemen. We see meteors because a rock or a piece of dust hits our atmosphere and therefore oxygenates. There's no oxygen.
No. What you're seeing, Ron, is this is a rock, a piece of stuff moving at tens of thousands of miles an hour. It ram heats the air in front of it and the air fluoresces. So that's what you're seeing is fluorescing air.
Yeah, it's a plasma shock wave.
Yeah. Does it also happen on other planets, even though they don't have a lot of oxygen around them?
Right.
It's not oxygen dependent. As long as they've got an atmosphere, you'll see meteors on that planet first. long
we
as you can survive.
Can we see them coming into our moon?
No
You can see
atmosphere.
'em. You can see them hit the moon,
Oh, okay.
but you don't see a
right.
trail before they land.
But you can see
You
them on
gotta have
Mars. The rovers have seen them on Mars.
Right.
even though they got 100 our atmosphere and
Yeah.
Yep.
And that's a big problem because it's hard to land on Mars because it has enough atmosphere to be dangerous, but not enough to work well with parachutes.
Yeah.
I love those old bouncing balls. Remember the big bouncing balls? Why don't they still use those? That's the way to
Because
land.
our spacecraft are too big for that now.
Oh, is that what it is?
So the reason we're showing the zodiacal light tonight is because this is the season where the angle is just right for sunlight to glint off this disk of dust, and it's not interfered with by the new moon. So this is your one
in the morning
chance.
sky too,
Yeah.
where the angle of the ecliptic is higher.
Yeah.
Mhm.
So if you go up to the some mountaintop around here and the fire department lets you in, then you stand a chance of seeing it. If you're also out in the ocean where there's no lights, you can see it too.
Are you saying they have just as much of a light problem down in Chile as we have here, even though it's
No,
not street lights?
Not anywhere near. This
Okay.
is a dark site. It will not look this bright up here.
Mhm.
I know, but down there, they can't see any stars in that white part of the sky we're looking at here.
You don't
No.
try to look near the horizon anyway, because then you're looking through a lot more air.
Right.
Mhm.
Oh, I see. Okay. Is this above where the sun set?
No, this is morning.
This morning sky, Ron.
Yeah.
So is it above what the sunrise
This
coming
is
up?
dawn. This
Yes,
is dawn
yes.
starting here.
That's right.
And that's where the sun will come up.
Yeah.
Yeah.
Oh, okay.
Right
got
up
it.
there. This is the ecliptic right there.
Ah, got it.
Very sharp angle, Ron. Very sharp angle in the morning.
Wow. Well, there's going to be telescopes all over northern Chile before long. There already is. That Atacama.
Chile is a long place.
Yeah, Ron, I just got a weather report from there.
Uh-oh. What's it say?
Chilly today, hot tamale.
I
Why
hope
we
you
have
weren't going there.
Yeah, you're right. Where are
Okay,
we?
this is
Saturn.
this is this evening. No, tomorrow evening at 8 o'clock,
Okay.
almost 9 o'clock.
Mhm.
And this is the moons of Saturn.
Mhm.
Saturn is this big yellow glob right there. Teddy's is this one, I think.
Yeah.
Enceladus is this one. This is Dione. This is Rhea. This
Mhm.
is Titan and Hyperion. And way over here is Iapetus. Now, if you get this field of view, you will not be able to see Iapetus because Iapetus is that moon that's half black and half white. And
Oh.
right now at this elongation is showing us its blackface. So it's many orders of magnitude too faint to be picked up. When it's on the other side, it'll show its white face and it'll be quite bright. So
Hyperion will be a bit of a stretch too.
yeah. So
It's
this is close in,
Uh-huh.
and here we see Tethys has just come out from occultation. Enceladus is going this way, and Dione and Rhea are the other two inner moons that you get if you look at it real close like this. And these rings are getting really, really thin right now. I think they're only about 3 or 4 degrees of angle for us to look at here. So in another, 5 months,
March.
another 6 months, they'll be, it'll look like the planet has no rings.
But now Enceladus is like Europa is to Jupiter. It's an ice moon that they're thinking might have life underneath the ice,
Yep, it's got an ocean.
Yeah.
more so than Titan. Titan's got an atmosphere, but it's all oil on the surface. And
Titan is more methane ice. It might have an ocean down below that.
wow. Well, we did have one probe give us a nice view as it settled in on Titan. Now we need one on Enceladus. I guess NASA's planning on going both there and Europa, right?
Yeah, they're going to be careful about landing on those moons because they don't want to contaminate them. But I was surprised to hear that I think it was JUICE is going to end its life crashing into Ganymede.
Yeah,
Oh,
I guess they don't have high hopes for life on Ganymede.
Or they want to introduce it.
Well, you can't land on an icy moon anyway because the heat would melt the ice and you just sink right down into anything.
This is crashing into it.
I think the ice would win.
Yeah.
Okay, now this is a close-up on September 7. This is from my planetarium shot, about as close as Mars gets to M35 right here. 8 p.m. on September 7, which is 4 days away, 5 days away.
Yeah, Mars is not even up then.
Jupiter is coming in from the side. There's a number of other things in here that are very nice. There's the star Propus right there. And we have these two nebulosities, which are IC things. Well, this is M35 up here. And the smaller one is
2158.
Yeah.
2158.
2158 NGC. Yep. Now,
You need a good dark night to pull out 2158.
yeah, this is a telescope object, definitely.
And it's much farther in the background.
Yes.
Is this the one that's like 16 times as far away?
Yeah, it's quite, I don't remember the ratio, but it's quite farther away.
You
Yeah, it's
notice the stars here are uniformly yellowish, which means there's more dust in front of that than there is in front of this.
That image there is why I bought a 13 Nagler Type 6.
Oh, I'm going to guess that fits.
It does. It would. Joe Doyle's responsible for that. He showed it to me up at the gun club one night, and I immediately went home and ordered the eyepiece. It was spectacular.
Ah, the jellyfish.
Yeah.
Is that what this is called?
Is this?
Now, this is a wide field image of IC 443, which is that those big blobs or white faint things you saw on the previous finder chart.
Oh, assuming the color is right, what does pink stand for? Oxygen? Hydrogen. Oh. So that's what we're looking at then.
And this star over here is Propus.
Okay.
Oh,
So going back, this is Propus here, and this is Mars. So I think it may be turned around the other way for that picture. But there's a lot of interesting things up here in this part of the sky. M1 is right there. Doesn't stand out. But a lot of good structure.
I'm really hoping that you get to the apple cookers. I've never heard that.
Oh, okay. Well, whoops.
Oh, I like this one.
Yeah. This one is, yeah, we'll be quick. This always throws me, this silly thing, but the W for Cassiopeia is here. And then Perseus is following along here. And right in the middle between the two is the double cluster right there.
And that'll be a fuzzy naked eye patch.
Right.
Really?
I always line it up with my eye.
I'd love to see it, but I live downtown.
And these are the two clusters. This one has some very nice red giants in it.
Yeah.
And if you look at this thing, when the sky is not completely dark yet, it's still dusky. These red giants stand out because of their contrast. But later at night, they're there, but they're not as easy to see. The color of them anyway.
And sometimes they can get really, really red looking because they're variables.
And I read somewhere that they were really interested in why 884 had the red giants and 869 did not. But here it shows that they did.
Yeah.
Couple.
Yeah, it's a beautiful object. One of my favorite in the sky.
Oh, yeah. Yeah.
Mm. 2 star clusters.
Now, the other oddity that Sky and Telescope, I think, pointed out was what they call Andromegasus, the Dipper. So they're making the Dipper out of Pegasus or Andromeda for the handle and the Dipper for
I see it.
Perseus.
Pegasus.
Pegasus.
Yeah, so this is it's much bigger than the Little Dipper or the Big Dipper, but you can see that it does form sort of its own pattern of a Dipper-like object out of the brighter stars in the region.
Yeah, dippers were big back in those days. I grew up with a dipper. We had a well and we'd fill the pot and that we didn't have running water, but there was a dipper.
So
Everybody
this name was proposed by a guy named George Lovey, who was a contributor to Sky and Telescope magazine.
Wow.
I always show people the hop, Jerry, from Alpheratz to Merock. You just count 1, 2, 3, and then you go up towards Andromeda, 1, 2, 3, and then just above that is Andromeda. I always show people to find the square and then find
Mirach,
find Alpheratz. So it's counting to 3 twice, and then Andromeda is just up to the right. Great star hop, and everybody else uses all these, the Dipper handle and everything, but I don't do that.
Oh, I do from Polaris right through Merak, find that, and then go up or down equal amounts.
Yep.
Are we heading for Apple Core here?
Oh boy, this
is.
Yeah, and I've never heard that name, Jerry. That is really fascinating.
That looks like an Apple Core.
It turns out that the Dumbbell Nebula, they had a thing that was weightlifting back in the 1800s, which was a metal bar, and they had 2 brass bells, one on each end, that had no clapper in them, and they were welded to the iron bar, and that was a bar bell. That's where the phrase came from. It was
a dumbbell because it didn't have the clapper.
That's right. It was a dumbbell bar.
Oh, interesting. I've never heard that. That's neat.
And this thing apparently reminded people of it because it flares out on the end and it looks like 2 dumbbells. But nobody knows what that means anymore, but everybody can resonate with the Apple Core.
Yeah.
Never heard that. Where did that come from?
Long time ago, someone.
The Apple Core?
Yeah.
Well, that's just people describing it, how it looks visually, going, that doesn't look like a dumbbell.
Yeah, I've never said it looked like a dumbbell, but this looks like an Apple Core.
Yeah.
Sky and Telescope says the earliest use of this name in print was in Google Books is from 1997. So it's a recent name.
It's not also HD 189733. That's a star to the left, isn't it?
Yeah.
That is correct.
And that's marked because it's a star with a transiting exoplanet. And there was a student, a high school student, that for her science project built a little tracker that she could put a camera on, and she would sit there and turn a screw at a certain rate, and she pointed the camera at this star during a predicted transit of the exoplanet, and detected the dipping in brightness.
That was Zoe.
Yeah.
Oh, wow. I remember her. I remember that.
Yeah.
So the name dumbbell was bestowed by John Herschel in 1828.
1828. I'll be darned.
Well, there's yearly competition among those beefy guys to use dumbbells. They're still around.
Yeah.
But
they
now
don't have bells on the end anymore.
No.
Apple Core. What happened to the rest of the apple? Well, it blew off. Should have a shell around it.
It fell to earth and begat a company.
God, there's a lot of stars in that picture.
It's an amateur picture, yes.
Is it really? Well, not all of them have names or even numbers, do they?
I think most of them have numbers.
Is that right? telephone
Especially
numbers like.
in the Gaia catalog.
Well, we covered it all. The Dipper, the coming fall, zodiacal light, Saturn, Mars. Now we got to put together a meeting on Friday night with Dr. Masiero talking about nasty asteroids and trying to get us and how they're chasing after them with what's
Infrared.
infrared. I can't think. Mr. Outreach, something about Refugio Canyon or yeah, the beach. Are we
Refugio State Beach on Saturday, Star Party.
okay?
And
then
then Telescope Tuesday on Tuesday the 10th.
And then the following Saturday, the second Saturday of September, we meet at the Museum of Natural
Yes.
History.
Yeah.
Well,
And we
okay.
have
On that
Thursday the
note,
12th at Carpinteria State Beach.
does anybody know what happened to our sixth member, Mr. Murdoch? Is he?
No.
Mr. Murdoch is taking care of his wife who has broken bones.
Oh, yeah. I would hope so.
And they have a house full of stairs and she's in a wheelchair.
Oh, bless his heart. He's going to heaven, that boy.
Yeah.
Well, let's do this again. Number 185 will be next Monday morning, 11 a.m. sharp, and we'll have the meeting to talk about. We'll see you there this Friday night. Gentlemen, take care of yourselves and your
Well,
ladies.
Not this Friday.
Yeah, it is this Friday.
Oh, I'm sorry. I'm thinking Star Party. Duh.
Our party is
Yeah.
the following. Yeah, I'll be at both of them if you need me in the dark. Meanwhile, thank you very much. Go online, check us out, people. We'll see you at Fleischman Auditorium on Friday night.